The success of hybrid seed maize cultivation in India depends on the successful seed production program, which enables the farmers to get adequate quantity of high quality seeds at reasonable cost. Hybrid maize seed production requires specialized techniques which need to be thoroughly understood before taking up this venture. Crossing technique or the breeding tool adopted for maize hybrid seed production is manual emasculation by detasseling. Detasseling is the process of removal of male inflorescence from the monoecious crop. The time taken for shedding of pollen from the tassel is 1 to 2 days after emergence. Hence, tassel should be removed before the shedding of pollen. Detasseling is to be done in the female parent when the tassel emerges out of the boot leaf but before the anthers have shed pollen. Anthers take 2 to 4 days to dehisce after complete emergence. Only in few cases the anthers start to dehisce before its complete emergence. In such cases, detasseling should be done earlier. Detasseling is done every day from the emergence of tassel up to 14 days. While conducting detasseling, the stem should be held below the boot leaf in the left hand and the base of the tassel in the right hand, and the tassel should be pulled out in a single pull. The entire tassel should be grasped so that all the pollen parts are fully removed. The leaf should not be broken or removed, as removal of leaves will reduce yield and will result in lower quality of seed. There are certain precautions to be adopted during detasseling. Let us see one by one. No part of the tassel should be left on the plant as it causes contamination. It should be an uniform process done daily in the morning in a particular direction. The top leaf should not be removed as the yield may be reduced due to the earning of source material to accumulate in the sink, that is the seed, and results in yield loss. Detasseling should be done only after the entire tassel has come out, and immature detasseling may lead to reduced yield and contamination. The male rows should be marked with a marker to avoid mistakes in detasseling. The shedders, that is the shedding tassel in the female rows, have to be looked out as they may cause contamination. After pulling out the tassel, it should be dropped there itself and buried in the soil. Otherwise, late emerging pollen from the detasseled tassel may cause contamination. The tassel should not be carried out through the field, as any fall of pollen may lead to contamination. Immature, improper and incomplete detasseling should not be practiced. Improper detasseling means a portion of the tassel remaining in the plant while detasseling. Immature detasseling means carrying out detasseling work when the tassel is within the leaves. Incomplete detasseling is the tassel remaining in lower or unseen or unaccounted in within the whole of leaves. There should not be any shedding tassel. Shedding tassel means either full or part of the tassel remaining in the female line after detasseling and shedding pollen, which may contaminate the genetic purity of the crop. In maize, there are different types of hybrids. Let us see one by one. The first one is single cross hybrid. It is a cross between two inbreds, that is A into B, in which A genotype will be detasseled and crossed with B genotype. For example, CoH1 is a single cross hybrid and it is a cross between the lines UMI 29 and UMI 51. CoH2, it is a cross between the lines UMI 810 and UMI 90. CoH-M5, and it is a cross between the lines UMI 285 and UMI 61. The next one is the double cross. It is a cross between two single crosses. It is a cross between two hybrids, that is A cross B, and it is crossed with the hybrid from C cross D. A into B single cross hybrid will be produced by detasseling A and by crossing with B. C cross D hybrid will be produced by detasseling C and crossing with D. Then the product from the cross A into B will be detasselled and crossed with C into D line. Examples for double crosses are Ganga 2, and it is a cross between CM 109 into CM 110, which is crossed with the cross between CM 202 and CM 111. And in COH3, the lines UMI 101 is crossed with UMI 130, and it is crossed with the cross between UMI 90 and UMI 285. The next one is three-way cross. It is a cross between a single cross and an inbred. It is the first generation resulting from the crossing of an approved inbred line and a certified open pollinated variety A, which is crossed with another variety. A will be detasselled and allowed for crossing in a variety. Example for this is Ganga 5, which is a cross between CM 202 and CM 111, and the resultant is crossed with CM 500. Another example is COH M4. In this, UMI 90 is crossed with UMI 285 and the resultant is crossed with UMI 112. The next cross is double top cross. It is the first generation resulting from the controlled crossing of a certified single cross and a certified open pollinated variety, that is A cross B, and this is crossed with a variety. A cross B line will be detasselled and crossed with a variety. Now let us see the seed production technologies. To start with, a suitable season should be identified. November, December, mid-July, January, February and September, October are suitable seasons. For hybrid seed production, the isolation distance is different. For inbreds, 400 meter isolation distance is for foundation seed stage, and for single cross hybrid also the isolation distance for foundation seed is 400 meters. The field standards for isolation can be modified based on the situation. For foundation single cross and hybrid of certified class, the foundation seed and for certified seed, the isolations will be different. If the kernel is of same color, then the isolation distance for foundation stage is 400 meters and for certified stage it is 200 meters. For the lines with different kernel colors, for foundation stage the isolation distance is 600 meters and for certified stage the isolation distance is 300 meters. For the field of single cross or inbreds not conforming to varietal purity, the isolation distances are 400 meter and 200 meter for foundation and certified classes respectively. For single cross with same male parent not conforming to varietal purity, the isolation distances are 5 meters for both foundation and certified classes. For single cross with other male parent not conforming to varietal purity, the isolation distances are 400 meters and 200 meters for foundation and certified classes respectively. Differential blooming dates are permitted for modifying isolation distance provided 5% or more of the plants in the seed parent do not have receptive silk, or when more than 0.2% of the plants in the adjacent field within the prescribed isolation distance are having shedding pollen. In hybrid seed production, for certified seed stage alone, the isolation distance of less than 200 meter can be modified by increasing the border rows of the male parent if the kernel color and texture of the contaminant are the same as that of the seed parent. The number of border rows to be planted all around the seed field to modify the isolation distance less than 200 meter shall be determined by the size of the field and its distance from the contaminant. For example, if the area of the field is less than 4 hectare and the isolation distance between the contaminant is 200 meter, then the number of border rows may be 1. If the area of seed production is less than 4 hectares and the isolation distance from the contaminant is 150 meters, then the number of border rows can be increased to 5 numbers. Likewise, depending upon the area and the isolation distance from the contaminants, the number of border rows may be increased or decreased. The spacing requirement for hybrid seed production may vary. For example, if the seeds are sown in ridges and furrows, for hybrids, the spacing is 60 into 25 centimeter. The seed rate for hybrid seed production is, for female lines, the seed rate required is 7 to 10 kg per hectare. For male line, the seed rate is 3 to 4 kg per hectare. The spacing for female line is 60 into 20 centimeter and it may be extended up to 75 into 30 centimeter depending upon the area. For male line, the spacing requirement is 45 into 30 centimeter. The most important aspect in hybrid seed production is synchrony of flowering. In male lines, the female synchrony can be brought about by staggered planting of male and female lines, manipulation in plant distance by spaced and narrow planting, irrigation control along with fertilizer application, application of farmyard manure in either male or female lines to induce earliness and vigor of the plant. A good seed set in the seed parent can be achieved by chronological adjustment of pollen shedding and silking respectively. Prolongation of effective flowering period, planting design, efficient alteration of rows, planting ratio, staggered planting are some of the measures which are effectively used to ensure maximum synchronization and good seed set. Now let us see the planting ratio and the border rows. The male is to female ratio depends upon the pollen shedding potential of male plant and male is to female synchrony. For better seed setting, flowering of female should be earlier than the male or male pollen dehiscence should coincide with the female silking. For single cross hybrid, the planting ratio is 4:2 and the number of border rows is 4. For double cross hybrid, the planting ratio is 6:2 and the number of border rows is 3. For three-way cross hybrid, the number of border rows is 4 and the planting ratio is 6:2. The layout of hybrid seed production plot can be seen in the picture. The fertilizer recommendation for hybrids is 200:100:100 kg of NPK per hectare. In this, 100:100:50 kg of NPK per hectare is applied as basal application and 50 kg of nitrogen is applied as first top dressing on 20th day, that is during the vegetative phase. The second top dressing with 50 kg of nitrogen and 50 kg of potash is applied during the boot leaf stage, which falls at 45 days after sowing. For hybrids, Foliar application of 2% DAP has to be given at 50% flowering stage. In zinc deficient soil, zinc sulphate at the rate of 20 kg per hectare should be applied. The most important practice in hybrid seed production is roguing. Roguing should be done periodically based on the position of the cob, color of the silk, arrangement of seeds in the cob, leaves, etc. The shedding tassels are to be removed during roguing. It refers to the tassels in the female parent rows shedding pollen or that has shed pollen in the hybrid maize plots. During field inspection, a tassel whose main spike or any side branch or both have shed pollen or shedding pollen in more than 5 cm of the branch length is counted as shedding tassel. During inspection, shedding tassels are taken into count for acceptance or rejection of the production plot. The field standards in hybrid maize seed production is for off types it is 0.2% for foundation seed and 0.5% for certified seed. And for shedding tassel, the maximum limit is 0.5% for foundation stage and 1% for certified stage. In this, when the receptive silk is 5% or more should be taken into account. When coming to inseparable other plants and objectionable weed plants, there should not be any such crop or weed in both foundation or certified seed stage. Some of the field standards which are specific to maize are the off types shedding pollen when 5% or more of the seed parent is having receptive silk and the permissible limit is 0.5%. The seed parent shedding pollen when 5% of the seed parent is having receptive silk, the standard is 1.0% in the certified stage. The total of pollen shedding tassel, including tassel that had shed pollen for all the 3 inspections conducted during flowering on different dates, the standard is 2%. The off type in seed parent at final inspection, the maximum limit is 0.5%. The number of inspections to be carried out in hybrid seed production field is 4. Inspections are mainly carried out by seed certification officers and 1 inspection is done before flowering and the 3 inspections are conducted during flowering. The kernel development was completed when a tough black layer has formed above the base called Duncan layer, and this layer seals off the embryo and the starchy endosperm. This is the physiological maturity stage. From this time onwards, harvesting may begin. At this stage, the moisture content of the kernel is high as 28 to 35%. As the maize seeds does not shed, ears can be left on the stalks until it becomes much drier, and harvesting should be done when the seed moisture content is 25%. Seed moisture content during different stages of maturation are: when the physiological maturity stage is seen, the kernels become hard, leaves will be green or only few top leaves will be green. In this stage, the seed moisture content will be 28 to 35%. When the physiological maturity has become full stage, then the kernels will be hard, the husks will be yellow in color and all the leaves will be in yellow color, and the moisture content at this stage will be 25% or less. Harvesting must neither be too early or too late. Harvesting too late is always accompanied by losses of seed due to shattering, attack by birds and rodents, and risk of infestation with insects. The pollen parents should be harvested first and then only the seed parent should be harvested. During and after harvesting, all the off types, diseased, damaged and doubtful cobs should be discarded. After reselection, the maize cobs should be dried and shelled. The maize ears harvested at 20 to 35% moisture content and shelled after reducing the moisture content to 15 to 20% results in the recovery of good quality seeds at higher proportions. The seeds are shelled either manually or mechanically. During threshing, the first operation to be carried out is dehusking. It is nothing but the removal of husks manually. The second step is cob sorting. It is the removal of ill-filled diseased cobs and cobs having kernel color variation. The most important aspect to be considered during cob sorting are xenia and metaxenia effects. The xenia effect is a direct or visible effect of pollen on endosperm and related tissues in the formation of a seed color. For example, the seed color in maize, the gene present in the sperm cell contributes in the expression of color of hybrid seeds. In metaxenia effect, it is nothing but the effect of pollen on the maternal tissues of the fruit. After cob sorting, the next post-harvest method is shelling of the cobs. The cobs are shelled either mechanically or manually when the seed moisture content is 15 to 18%. Improper shelling leads to 48% damage to the kernel, resulting in growth of storage fungi and pericarp damage. The crack on the pericarp can be identified by ferric chloride test or tetrazolium test. The shelling is done manually by rubbing the cobs with stone and mechanically by using cob shellers. After the seeds are extracted, the seeds have to be dried to 12% moisture content. After drying, the seeds have to be graded using 18 by 64 inches sieve. After grading, seed treatment has to be given. The seeds are slurry treated when they are in 8% moisture content, either with Kapton or Thiram at the rate of 70 grams per 100 kg with 0.5 liters of water. The treated seeds can be stored for 1 year in cloth bag. The other post-harvest operations are similar to that in varietal seed production. The seed standards for hybrid maize is the physical purity percentage should be minimum of 98% and germination percentage for inbreds and foundation stage should be 80% and for certified seed it should be 90%. So far we have studied the hybrid seed production in maize and the method adopted for hybrid seed production, that is detasseling, procedures and precautions to be adopted during detasseling, various types of hybrids in maize, pre-harvest and post-harvest operations in maize hybrid seed production.